recorded this FRQ once and then it crashed, and so to save a little time I'm not going to rewrite, but I will talk through it. So as I'm reading the problem, what I notice, that's not what I want, so eraser. So as I'm reading the problem, what I notice is f and g are differentiable. G is strictly increasing. The table above gives values of the functions and their first derivatives. So I stop there and I look up. I comprehend what I'm seeing. I see x here and f prime, g prime. The function h is given by this formula. Explain why there must be a value r where r is between 1 and 3, such that h of that r is negative 5. So because the r is in the spot where the x belongs, I figured out that r is an x coordinate. Okay, what I do next is basically memorization. This phrase I have memorized from doing a lot of AP tests is pointing me towards what's known as the intermediate value theorem. Didn't have room on the golden notes for that, but it's a really simple idea. So between x equal 1 and x equal 3, let's go find out what the y coordinate is at x equal 1. So we're going to plug into the formula. So we plug in a 1 for x. G of 1, so when x is 1, g has a value of 2. So g of 1 is 2. F of 2, so when x is 2, f has a value of 9. 9 subtract 6 is 3. So we figured out that h of 1 is 3. Now we need to go find out what h of 3 is. So do the same thing. H of 3 will be f of g of 3, subtract 6. G of 3 is 4. So now we have f of 4. F of 4 is negative 1. So h of 3 is negative 7. So the intermediate value theorem is a really simple idea. You have an x coordinate of 1, and at x equal 1 on the graph of h, the y coordinate is 3. And you also have, at x equal 3, a y coordinate that is negative 7. Okay, they tell us that f and g are differentiable, which means f and g are also continuous. So h, which is comprised of f and g, would have to also be differentiable, meaning h is also continuous. So here's h. You start here at a y coordinate of 3. You've got to get to a y coordinate of 7. This was a mistake here. This should have been a 3 here. Sorry. There's no way to get from all the dots that comprise h to here unless one of these dots has a y coordinate whose value is negative 5. That's essentially the intermediate value theorem. Now, writing it down is a bit wordy. I have to have everything in green. I have to say, because h is differentiable, therefore h is continuous. The intermediate value theorem is only valid if h is continuous. So I have to state that. So by the intermediate value theorem, since h of 1, which was, again, back here, h of 1 had a value of 3, since h of 1, which was equal to 3, is greater than negative 5, just like you see in the picture here. Negative 5 is in here somewhere. And h of 3, which was equal to negative 7, because negative 5 is between these two y coordinates, the intermediate value theorem says there will be an x coordinate, they're calling that x coordinate r, between x equal 1 and x equal 3, such that the y coordinate at that x is negative 5. That's the intermediate value theorem. I think it's not too bad to, with some practice on FRQ tests, recognize that they want you to use the intermediate value theorem. Therefore, you know you must find the y coordinates at the two x coordinates given. So that's why I needed this and this. If you find these two pink boxes, they will give you 1 point. You don't really have to show any work. If you find the two pink boxes, you write them down, you can do the work in your head, they'll give you 1 point. To get the second point, you would have to write out all that you see here in green. If you don't have all of those words, they won't give you the second point. So this is problem 3A, is worth 2 points total. 1 point for h of 1 and h of 3 being found correctly, 1 point, and 1 other point for the green.